Hello everyone, myself Brunda. I am studying at Shri Venkateshwara College of the Engineering 4th SEM ISC. Let me discuss today about the factorial function, overview, introduction, general plan for recursive algorithm, factorial pseudocode, analysis, C code for factorial number. Introduction, factorial definition. Factorial is a function that multiplies a number by every number below it till 1. For example, factorial of 3 represents the multiplication of numbers 3 into 2 into 1 equal to 6. Recursion. In simple terms, when a function calls itself is called a recursion and the factorial of the n. The factorial of n is denoted as n factorial and it is equal to 1 into 2 into so on n minus 2 into n minus 1 into n. Factorial function using recursion. Factorial of n equal to 1 when n equal to 0 or the 1, and the factorial of function equal to f of n minus 1 when the value n greater than the 1. So if the value of n is either 0 or the 1, then the factorial returned is 1. If the value of n is greater than the 1, then we call the function with the n minus 1 value. We can see here we have the two conditions. When the value of n equal to 0 or 1, we call the function factorial function equal to 1. If the value greater than the 1, we call the factorial function into n minus 1. Example, let me take the value 3 which is greater than the 1. So f of n is equal to n into factorial of n minus 1. Substitute with the place of n with the 3. F of 3 is equals to 3 into factorial of 3 minus 1. So we get the equation 1 as 3 into factorial of 3 minus 1 equal to 2. 3 into factorial of 2. Next we need to find the factorial of 2. Next in the place of the n substitute with the 2. F of 2 is equal to, in the place of the n you substituting into 2 into factorial of 2 minus 1, we get the factorial of 1. As per the condition we know that factorial of 1 will be 1. So 2 into 1 equal to 2. Then we need to substitute the factorial of value of the 2 in the equation 1 for this equation to find the factorial of the 3. Next, f of 3 is equal to 3 into factorial of the 2. We know that the factorial of 2 is the 2. So 3 into 2 equal to 6. This is the how we find the factorial of 3. General plan for the recursive algorithm. Let me see the general plan, how to analyze the recursive algorithm for the factorial code. Decide the input size based on the parameter n. Identify algorithm's basic operation. Check how many times the basic operation is executed. Set up the recurrence relation with some initial condition and expressing the basic operation. Solving the recurrence, we will use the forward and backward substitution method. Factorial pseudocode. The algorithm of the factorial of the function is algorithm factorial of the n, and it is the first statement is used as a purpose. This algorithm computes n factorial using the recurrence function, and it is the input a non-negative integer n, and the output it returns the factorial function. If the value of the n equal to the 0, it returns the 1, else return factorial into n minus 1. And the analysis of the factorial algorithm is integer n is the input to the algorithm. We can give any n values, and the basic operation to the factorial is multiplication. We saw here the basic operation is multiplication. We can see 3 into factorial of 2 and 2 into factorial of 1. The basic operation is multiplication, and there will be no cases, worst, best and average case. And the recurrence relation f of n is equal to n into factorial of n minus 1 when the n value is greater than the 0. The number of multiplications are m of n is equals to m of n minus 1 plus 1, where the m of n denotes the number of multiplication for finding the factorial of n minus 1. This is the value of m of n to find the factorial of n minus 1, and the 1 is the multiplication for multiplying the n into factorial of n minus 1, and the 1 is the value used for the multiplying n into factorial. See here, n into factorial of n minus 1. Initial condition m of 0 is equal to 0. For the factorial, we take the initial condition of m of 0 will be the 0, and the m of 0 the call stop when n value become the 0, and the 0 no number of the multiplication when the n equal to 0. And we have the condition of when the value of the n greater than the 0, m of n is equals to m of n minus 1 plus 1. By using, we need to substitute with the help of the backward substitution method. And with the help of the base condition, we know that m of 0 will be the 0 as the initial condition, and the m of n is equals to m of n minus 1 plus 1. we need to substitute the value of the n with the n minus 1 and the n minus 2. When we substitute the value with the n minus 1, we can see here, when you substitute the value of the n, as I took the equation 1, no, when you substitute the value with the 1, m of n minus 1 is equals to m of, in the value of the n with the n minus 1, m of n minus 1 minus 1 plus 1 we get. See here, m of n minus 1 minus 1 plus 1. So this equation m of n minus 1 become m of n minus 2 plus 1. Next, you need to substitute the value of the n with the n by n minus 2. When you substitute with the n minus 2, m of n minus 2, it is m of n minus 2, and you need to substitute m of n minus 2 minus 1. It becomes m of n minus 2 minus 1 and the plus 1 as it is, plus 1. M of n minus 2 is equals to, we get m of n minus 3 plus 1. Why we use the backward substitution way means, we find the n minus 1 and the n minus 2 and we substitute to the original equation. For the first equation, m of n is equals to m of n minus 1 plus 1. So it is called as the backward substitution method. When we need to, I find out the value of m of n minus 1, m of n minus 1 is equals to m of n minus 2 plus 1. Substitute it is plus 1. So we get m of n minus 2 plus 2. And we know that m of n minus 2 is equals to m of n minus 3 plus 1. Substitute it here, m of n minus 3 plus 1 plus 2, we get m of n minus 3 plus 3. We need to try to make the value as the 0, because as per the initial condition or the base condition, m of 0 is equal to 0. We know that. See here, in the initial condition is m of 0 need to be 0. So try to make the m of n minus 3 plus 3 equation as the 0. So substitute the 3 value as the n. See here, m of n minus n, 3 value as the, I took the 3 value as the n plus n. We get that m of 0 plus n, m of 0 as per the condition is the 0 plus n, we get the n. The number of the multiplication required to find the factorial of the n is n factorial. C program for factorial number. Let me discuss the C program for factorial of the number. Okay, let me take the integer value with the n, I and the fact is equal to 1 to store the value. With the initial, I took the value as the 1 and we need to enter the number. Let me take the number with the 5, n is equals to 5 and the scan and the scanf take place, and for I is equals to 1. Example, I is equals to 1 and I took the value n as the 5. 1 is less than or equal to the 5. So we have the fact is equal to fact into I. Fact is equals to 1 into I took the 1, we get the value as the fact is equals to 1. Next, the I value will be incremented. I will be 2. 2 is also less than or equal to the 5. So where the first, before the fact value is the 1 and we multiply with the 2, we get the value as the 2. And the 2 will be incremented. We get the I value as the 3. And 3 is also less than or equal to the n as the 5. So we have the fact value as the 2. 2 into 3, we get the value as the 6. Next, the I value incremented from the 3 to 4 and the 4 is also less than or equal to the 5 and multiply we have the fact value as the 6. 6 into 4, we get the value as 24 and the I value is incremented to the 5. 5 is also less than or equal to the 5. So the fact value, before we have the 24 into 5, I value as the 5, we get the 120. So the output and the I will be incremented to the 6 and the 6 is not less than or equal to the 5. So the condition fails and the printf, the factorial of percentage d is percentage d n into fact. The factorial of percentage 5 is 120 and the output will be like when we enter the value of the 5, we get the output as 120. When you enter the value of the 3, we get the output as 6 and when you enter the value of the 4, you get the output as 24. Thank you.